So in this video, we're going to go through the concept of the juicy burger experiment. And I'll lay out a couple pieces as we get ready to scroll. But we're focusing at the moment on the four key principles of a good of a good experimental design. That's comparison, control, random assignment, and replication. Now, we might have these to a varying degree, sometimes good, sometimes bad, but let's go ahead and look at that in the context of the scenario that I'll set up here. We have a company that wants to measure how juicy its burgers are. And it's designed an experiment that it thinks is good, but I guess we're going to figure out maybe can be tweaked a little bit and made a little bit better. So here's the scenario. The company wants to see which method of cooking, 3 minutes, 450 degrees, 4 minutes, 375 degrees, 5 minutes at 300 degrees, which of those, we'll call them treatments, will provide the juiciest burger, the one that they'll think be best for their customers. And to run their test, what they did is they happened to have 3 ovens available. And so they set one to do 3 minutes, 450, another to do 4 minutes, 375, and the other one to do the 5 minutes, 300 degrees. And they're going to throw 30 burgers on each and compute the juiciness using some different moisture content tracking devices that they happen to have. And the way they set it up is they were just going to work from 3 of their different, quote, burger bins. And it turns out they buy patties from a few select suppliers, Company A, Company B, Company C. And this particular scenario that they set up, those bins, those burger bins that they happen to have, hold 500 burgers from each of the different companies. They're going to take from Company A, they're going to randomly select 30 of those burgers, throw them onto oven 1 for 3 minutes and 450 degrees. Burger 2 from Company B, they're going to do the same thing with that bin or whatever. Grab 30, randomly chosen from in here, throw them onto the second oven, and so on and so forth. They'll get all these after they're cooked, they'll measure the moisture content, and they'll try to compare and contrast. So this is, quote, an okay experimental design, but it's missing a couple pieces when we talk about control. And one of the key things that they're kind of missing here is variability. We might assume that the 500 patties from each of these companies, at least, companies A's patties, there's going to be some chance differences in how moist they'll wind up after they're cooked or whatever, because each of those patties is slightly different, even though they're built or manufactured to a certain specification. There's going to be some what we'll call chance variability there. And that's going to be true across the other companies. And we've talked in the past about confounding variables. How can some additional variables kind of get in the way of the quality, so to speak, of our experiment? Well, there's a couple confounding variables that we can see here. Number one is just, hey, the burgers are coming from different places. And I wouldn't be surprised if each burger company, maybe their burgers have variations in how juicy they are. They might be very consistent within, but across each other, I wouldn't be surprised if there's some differences in the juiciness of these different burgers from the different companies. And another thing that's probably something we need to think about from a confounding standpoint, maybe these ovens are different. Maybe oven 2 is real old. Maybe it hasn't been maintained well. Maybe it actually, when we set it 375, it runs a little bit higher. There could be different variations, different variability is a better way to describe it, of the performance of this. So we're lacking a good degree of control in our experiment. There's some good aspects. We're randomly assigning the burgers. We are trying to do some type of comparison. It's at least a legitimate comparison in our minds. Replication, we're not just throwing one burger on in each of these ovens and trying to make our conclusions. We have a decent number. We're taking 30 out of there. But how can I handle this a little bit better? How can I start to deal with my confounding variables? Control is one aspect. So I'm going to talk through 2 ways in which this will be handled in the experiment to make it, quote, better. First things first, we're not going to use 3 different ovens. We're going to solidify and just work with one oven. We'll run multiple iterations with that oven. We'll cook for 3 minutes and 450. We'll cook for 4 minutes, 375. We'll cook for 5 minutes, 300. But we're going to do that all on one oven. So variations in performances across the ovens will not impact the variability of our results in our experiment. We're going to control for the oven variability by working with just one oven. And then most importantly, what we're going to do is we're going to implement a blocking design. We're still going to test 90 burgers, but we're going to do it in a different way. We're going to recognize and realize that there are variations across the 3 burger bins because they are burgers from 3 different companies. And so here's what our new design will look like. First things first, we have control because we're going to do 1 oven. There are, even though there is minutes and degrees, that's 1 treatment. Don't think, oh, there's 2 treatments there. 3 minutes is a treatment, 450. That's a combination. That's how we're going to work here. So 3 450, 4 375, and 5 300 is a treatment. Now you're seeing a whole bunch of different colored arrows here. You're seeing some red ones, you're seeing some pink ones, and you're seeing some black ones. That's because we've now blocked by the companies. Each burger bin. What we're going to do, we're still going to take 30 out of the 500 from each. But now we're going to what? We're going to account for the variability across the different companies by taking what? 10, 10, and 10, getting the 3 450 treatment. 10, 10, 10 in pink, getting the 4 375. And 10, 10, 10 in black, getting the 5 300. We've accounted for the variability here, or at least we've done a better job of accounting for the variability. That's the best way to describe it. You cannot perfectly account for all variability. There's always going to be chance in the world. But here, what we have done is we've handled the variability between the different manufacturers, the 3 different burger companies. And that's the beauty of a block design. We have variability between the 3 companies. We've started to mitigate and to handle that by using this block design. And the added benefit that we got is this extra piece of control. I don't necessarily need to do control. I could send 10 burgers. I could do a real big amoeba here where I'd be going into 3 different ovens and having comparisons. That's getting very unwieldy. This is a simple structure that's still pretty manageable. And when all is said and done, coming out this other side up top, that's where I'll be doing all my juicy calculations. And that's where I'll be doing all my comparisons. I'm going to have a much better idea now about which of these 3 combinations, these 3 treatments, which one produces the juiciest burger. So there's our burger bin problem. Hope this helps a little bit.